We are starting with the next chapter in class 10th of chemistry, that is metals and non-metals. So first of all, we'll study what are metals. How many elements we know? We say approximately we know 118 elements, and out of these 118 elements that we know, and this is approximately 91 are metals out of these. And some examples of metals are like iron, copper, aluminium, gold, zinc, silver. These are examples of metals. So first we'll study the physical properties of these metals. Physical properties of metals. In physical properties, the first property that we are taking is a physical state of the metals. Physical state means how it looks. What is the physical state? It is solid, liquid, or it is in a gaseous state. So metals are in a solid state at room temperature we take. Because when we heat them, of course, they will melt. So at room temperature, most of the metals, they are in a solid state. Like we know all these examples that I've written here, same examples we can write here. Iron, copper, all these are in a solid state. But one exception we are doing here, and that is mercury. This is an exception. It is in a liquid state at room temperature. At room temperature, this is in a liquid state. Now moving on to the second physical property of metals, luster. Luster means shine. And most of the metals, they have a shiny surface. The metals, they are shining. Like for example, copper if we take, silver, gold, all these, they have a shiny surface. And because of this only the reason we use gold, silver in making of jewelry. Third property, that is malleability. Malleability means when we beat the metal, we take a piece of metal and we beat it with a hammer and it will change into the thin sheet. So changing of metal to the thin sheets by hammering them, this property is known as malleability. And best malleable metals are gold and silver. Best malleable metals. We can make very thin sheets of the gold and silver metal. Next is the ductility. If we pull the metal from both the sides, it can be drawn into thin wires. So if metal can be drawn into wires, this property of changing the metal into wires is known as ductility. And the best ductile metal is gold. Gold is the best ductile metal. If we take, like for example, 1 gram of gold we take, from this we can get a gold wire for approximately 2 kilometer length. So this is the best ductile metal because just from small amount, 1 gram of this amount, we can get approximately 2 kilometer length of the gold wire from this. After ductility, next property is hardness. We all know that metals are very hard. Generally, they are very hard. Iron, copper, all these zinc metals are very hard and we cannot cut these with a knife. But we have an exception here, sodium and potassium metals. These are soft metals and we can cut them with a knife. These can be cut with a knife because these are very, very soft. Next physical property of metals after hardness, the sixth property is thermal conductivity. Thermal means heat. Conductivity means conduction. So they conduct heat. This is called thermal conductivity. Metals are good conductors of heat. That is why the utensils that we use in a kitchen for cooking purposes, all these are made up of metals. So when the outer side of these vessels, they are heated, the heat goes inside from outside to inside. So metals are good conductors of heat. The best conductor of heat is a silver. Silver is a best conductor of heat. But again, here also we have some exceptions. Lead is not a good conductor of heat. It is the poorest conductor of heat. And then mercury, this is a poor conductor of heat. It is a poor conductor of heat. Next physical property after thermal conductivity is electrical conductivity. Now here conductivity is the electrical. Electrical means electricity. And since we are doing metals here, metals, they have electrons in them. This is an atom of metal. They have electrons. These electrons are free electrons. And these free electrons of metals, when they are moving, this movement of the free electrons only is known as current. So electrical conductivity of metals is due to the presence of free electrons in them. And these electrons only, they conduct electricity. Again, the best conductor of electricity is a silver metal. It is a best conductor of electricity. But the wires that we use for conduction of electricity are not made up of silver. These are actually made up of copper. The reason is because silver is a costly metal. So copper is used and it is the second best conductor of electricity and not expensive like that of silver. So copper is used for the conduction of electricity for the making of wires. Next property after thermal and electrical conductivity of metals is melting and boiling points. Melting points means the temperature at which the solid metal will melt. It will start changing to the liquid form. Now here tungsten has highest melting point. And why melting points are very high of these metals? Because in case of metals, they are linked by the atoms of metal are linked by the strong metallic bonds. So high energy is required to break these bonds and then only metals they will melt. So highest conductivity is of the tungsten metal, and then copper also has a high melting point. While if we take sodium and potassium metals, these have low melting points because these are soft metals, so atoms are not packed closely. Similarly, if we take gallium and cesium, their melting points are very, very low, exceptionally very low. Exceptionally very low melting points are of which metals? That is the gallium and cesium. After melting and boiling, similarly their boiling points also they are very high. Next property after melting and boiling points is sonority. Sonority means if we take two pieces of metal and struck them, they produce a ringing sound. So that property is known as sonority. So metals, they produce ringing sound. They produce ringing sound when two pieces of metal they are struck. When struck with a hard substance or two pieces of metals when we struck. And because of this property, these metals they are used for making of bells and even for making of strings of musical instruments like sitar and violin. Their strings are made up of metals. Next property after sonority is strength. Metals are very hard, and because of hardness of the metals, the strength of metals is very high. So metals have high strength, and this is a reason why we use metals to hold the large weights in them. We can store the liquids in these containers. Large weights can be stored in the metal containers because the strength of the metals is very high. Next property is color. Most of the metals are usually gray in color or silver in color. Usually metals we get in which color? Silver or gray color. But some metals like copper, this is reddish brown in color, and gold, this is yellow in color. These are the physical properties of metals. After doing the physical properties of metals, now we are doing the investigation of some of these physical properties. Investigations to study some physical properties of metals. The first one we are taking is to study the hardness of metals. We all know metals are very hard, but how we'll study that metals are very hard? For this, what we'll do is we take the samples of iron, copper, for example, we will take here, then aluminium we can take, and magnesium metals. So some of the metal samples we will take, like these we have taken. And now what we'll do is try to cut these with knife. Is it possible to cut these metals with knife? No, we cannot cut these metals with knife because these metals are very, very hard. But if we take sodium or potassium metals, so take sodium metal, but we have to hold it with a pair of tongs. We cannot hold it with our hands because this can burn in our hand. It's a very reactive metal, so we have to hold it with a pair of tongs. And before cutting this metal, we have to dry this. So press it between the folds of filter paper. We know that sodium metal we store in a kerosene. We cannot keep sodium metal outside like this only. It's always stored in a kerosene. So when we'll take it out, we hold it with a pair of tongs and then we have to press it between the folds of filter paper. And now we have to, and now cut it with knife. Is it possible to cut it with knife? Yes, with a knife. So this is what we have to do in this investigation, and then observation. And what is the result? Observation and inference. Observation here is that it is possible to cut the sodium metal with a knife, but it's not possible to cut all these metals with a knife. So our conclusion from this thing is metals are hard, and hardness varies from metal to metal. But then we'll write that sodium is soft because it can be cut easily with a knife. So this is the first investigation. Second investigation is to study the malleability of matters. To study malleability of matters, that we can change the metals to the thin sheets. For this, what we will do is that again we'll take some samples of metals, like we can take iron here. Just small pieces we have to take of these, of iron. Then zinc we can take, lead we can take here, copper metal we can take, and place these metals on a block of iron like this. A block of iron we'll take, and one by one we will keep these small pieces of metals in this block, and we have to hammer them. 3 to 4 times we have to hammer this small piece of metal, and then we will see that can these metals be changed to the thin sheets on hammering them. Observation is that metals can be easily beaten into thin sheets. This is a result, they can be easily beaten into the thin sheets, and this property of metal is known as malleability. So this proves this thing that metals are malleable. Next is to study the ductility of metals. For this we just have to take few pieces of metals, and we have to see whether these metals are available in the wire form or not. Just check that these metals like iron, copper, aluminium, lead, try to find out that which of these metals are in the form of wires. So we will get wires of most of the metals. That means the metals, they are ductile. Most of metals are available in the form of wires, and this ability of metals to be changed into the wires is known as ductility. Next property we are taking for investigation is to study the thermal conductivity of metals. We have to check that metals are good conductors of heat. To check this property, we will take an aluminium or copper wire, and we have to clamp it on a stand. This is a stand that we are taking, and on the stand we have to clamp this is a clamp. This is stand. On the clamp here we'll take a wire. This is a wire that we are taking here. Aluminium or copper wire we can take. So this part I'm labeling is that this is a metal wire. Now take a small pin and attach a pin to the free end. This is the free end of the metal. Here we have to attach a pin, but pin we cannot attach like this only. So what we do is we take a wax, and with wax only we fix this pin here. So this is a wax. With wax we are just putting up the pin with the wire. This is the free end of wire. Now what we'll do is we have to heat this metal wire. So heat the metal wire, but which end of this wire we will heat? The end that is close to this clamp, this side. So that end only we are heating. On heating this end, this is the experiment. Now observation and inference here. What we will observe and what conclusion we will make from this thing. Observation and inference. When one end of the wire is heated, the wax on the other end will melt and the pin gets detached from this wire. This can happen only if the heat from this end can move to the other end. That means metals are conductors of heat. That is why here the wax will melt and the pin will detach from this wax. This shows that metals are good conductors of heat. Metals are good conductors of heat. This we can prove from this investigation. Now next one after this is the fifth investigation, to study the electrical conductivity of metals. The metals are good conductors of electricity. How we can investigate this? For this, what we'll do is take some metals and take these metals in the wire form, and then we have to set up an electrical circuit like this. We'll take a battery, or like we can take a cell here, and then there's a wire here. This is attached to a clip. Two clips we are taking. One is A clip, one is B clip. So this is A, this is B, and these are clips. This is battery. The two ends, one end connected with the clip and this another end, this wire, this we are connecting with the bulb. This is also a wire, and this side, this is connected to a switch here, and this is connected to this clip. This is the setup that we have. This is switch, electric circuit, this is bulb, and here we'll insert a piece of metal that we want to test. Now this circuit here is broken here. To join this circuit, we are taking a piece of metal here, that is we are taking a wire of metal and we put it here and we close this circuit. If that piece of wire that we connect here is a conductor of electricity, then the bulb will glow. So in this case, when we insert a sample that we want to test, so when we use the metals here, the bulb will glow because the metals are good conductors of electricity. So this experiment, this setup, this proves this thing that metals are conductors of electricity. So these are some of the investigations for the physical properties of the metals. With these physical properties of metals, they are complete.